Imagine, just for a moment, that the universe we see the stars, the galaxies, the endless darkness stretching beyond sight-tease, only one small bubble in an infinite cosmic ocean. That somewhere beyond the limits of our telescopes and the reach of our physics, there are other universes. Some may look much like ours, with stars burning bright and life flourishing on blue planets. Others could be so different that they defy imagination realities where time runs backwards. Light behaves differently, or the very idea of you is rewritten in another form. This is the idea behind the multiverse theory, one of the most fascinating and controversial concepts in modern science. For centuries, humanity has asked a simple but haunting question: is this all there is? We used to think Earth was the center of everything. Then we discovered the sun, then the galaxy, then billions of galaxies beyond. Each step revealed that we are smaller and smaller in the grand structure of existence. The multiverse pushes that idea one step further. It suggests that even our entire universe, the vast cosmos of all we know, might be just one tiny speck among countless others. The story begins with the Big Bang, about 13.8 billion years ago, according to our best models. The universe began as a singularity, a point of unimaginable density and heat and expanded outward, cooling and forming matter, stars, and galaxies. But as physicists studied the mathematics of this event, strange questions arose. If the Big Bang was a single explosion of space and time, what triggered it? And could it have happened more than once? Here's where the mystery deepens. Some versions of cosmic inflation theory, first proposed by Alan Guth in the 1980s, suggest that inflation, the rapid expansion of space after the Big Bang, may not have stopped everywhere at once. It might still be happening in distant regions beyond what we can observe. In those distant patches, new bubble universes could be forming all the time, each with its own laws of physics, constants, and even dimensions. Our universe would then be just one bubble in a vast foam of universes, a multiverse. This picture of eternal inflation paints a reality both beautiful and unsettling. Each bubble universe could be completely disconnected from ours, forever unreachable. No telescope, no spacecraft, no signal could ever cross the cosmic boundary between them. We may never know what's out there. Yet, logically, the possibility lingers, mathematically sound, physically plausible. Imagine an endless sea of universes, each born from quantum fluctuations, each expanding with its own clock of time. In one universe, gravity might be slightly stronger, making stars burn out before life begins. In another, atoms could be unstable, leaving only darkness. And perhaps, in one very familiar universe, there's a version of you reading this same story in a slightly different way. This brings us to another branch of the multiverse idea, the quantum multiverse. At the smallest scales of reality, quantum mechanics tells us that particles can exist in multiple states at once, only choosing a definite state when observed. The many worlds interpretation, proposed by Hugh Everett in 1957, takes this idea to its bold conclusion. Every quantum decision creates a branching of realities. In one branch, a particle spins left. In another, it spins right. Extend that to every atom, every molecule. Every neuron, and you get a universe constantly splitting into countless versions, each containing a different outcome of every event. In this view, there isn't just one timeline where you exist. There are infinite yous, living infinite possibilities. One where you stayed home instead of going out. One where you made a different choice years ago. One where you never existed at all. Each of these universes is as real as ours, just inaccessible, branching out like the limbs of an endless cosmic tree. It sounds like science fiction, but it's grounded in the strange mathematics of quantum physics. We can't observe these other worlds directly, but neither can we rule them out. Every experiment in quantum mechanics supports the idea of uncertainty and superposition, both of which make the many worlds model logically consistent. Other scientists have imagined multiverses from different angles. Some theories of string theory propose that our universe's fundamental particles are tiny vibrating strings, existing in higher dimensions beyond our perception. In this framework, there could be multiple solutions to the equations that describe the shape of space-time, each corresponding to a different universe with different physical laws. If our cosmos is like a single note in a vast cosmic symphony, then the multiverse would be the entire melody. There's also the brain world hypothesis, which emerges from M theory. It suggests that our universe exists on a three-dimensional brain floating within a higher dimensional space. Other brains could drift nearby, invisible to us. If two brains were ever to collide, it might create a new Big Bang, a new universe born from the impact. In that sense, universes might not just appear randomly, they might interact, giving birth to new realities through cosmic events far beyond our comprehension. But here's the profound challenge. If we can never observe these other universes, how can we ever know if the multiverse is real? Science relies on evidence and measurements, predictions, and tests. The multiverse, by its nature, may lie forever beyond our observational reach. Some physicists argue that it's not truly science if it can't be tested. Others counter that, if the mathematics is consistent and the theory explains phenomena we can observe, such as the fine-tuning of physical constants, then it deserves consideration. Speaking of fine-tuning, the multiverse may offer an explanation for one of the biggest puzzles in cosmology. Why is our universe so perfectly suited for life? If the strength of gravity or the charge of the electron were slightly different, atoms might not form, stars might never ignite, and life would be impossible. Why did the universe get it just right? In a multiverse, it doesn't have to be chance or divine design. Could simply be selection. Out of countless universes, most are barren and uninhabitable. We just happen to live in the one where life can exist. It's not that the universe was made for us. It's that we appear in the universe that allows us to exist. Still, the philosophical implications are staggering. If there are infinite universes, does that mean there are infinite versions of you each, living a different life? Does free will exist if every possible choice is realized somewhere? And if there's a universe where everything that can happen does happen, then what does reality even mean? Perhaps the multiverse is less about physics and more about perspective. It reminds us how limited our view truly is, how much of existence might lie beyond our reach. We've always lived inside bubbles of knowledge. First our village, then our planet, then our galaxy. The multiverse asks us to imagine the next step, to accept that reality might be more vast and varied than our minds can fully grasp. Some scientists believe that future discoveries could give us indirect clues. The cosmic microwave background, the faint afterglow of the Big Bang might hold subtle patterns, like bruises or cold spots that hint at collisions with other universes in the distant past. If such evidence were ever found, it would shake the foundations of science and philosophy alike. Until then, we remain explorers in a single universe, peering into the darkness and wondering what lies beyond. Whether the multiverse is real or not, it captures the essence of human curiosity, the urge to look past the horizon and ask, what else is out there? In a sense, the multiverse lives not only in equations, but in imagination. It's a mirror reflecting our desire to understand existence itself. Maybe we'll never prove it. Maybe we're not meant to. But even the act of considering it expands our minds and deepens our awe for the cosmos. Because if the multiverse is true, then somewhere in another universe, another version of you is also wondering the same thing, looking up at their night sky, asking the same question, dreaming the same dream. And that thought alone makes our universe feel a little less lonely.